Welcome to the Bedtime Lab, a gentle sanctuary where we drift into the fascinating world of sleepy facts. I'm so glad you've decided to join me this evening as we explore the captivating story of how the universe's elements came to be. It's like delving into an ancient tale where stars are storytellers and the cosmos is our library. As we embark on this soothing journey, I'd love to know where you're tuning in from. Feel free to share in the comments. It's always wonderful to connect with curious minds from around the globe. Now, let me share something truly intriguing with you. Did you know that the elements we find in the universe were forged in the hearts of stars? It's a beautiful thought, isn't it? These gigantic celestial forges, where temperatures reach millions of degrees, create elements through a process known as nuclear fusion. Imagine the sun, our closest star, constantly weaving hydrogen into helium, giving birth to new elements as it shimmers across the sky. Speaking of stars, here's another fascinating fact. Not all stars create the same elements. You see, smaller stars like our sun primarily fuse hydrogen into helium. But larger, hotter stars have the power to forge heavier elements. These stars, in their final days, perform a spectacular dance of creation in their cores, forming elements like carbon, oxygen, and even iron. Can you imagine the universe as a grand cosmic factory, with different stars producing a varied catalogue of elements? Now, you might be wondering about elements heavier than iron. These elements are not born in the regular life cycle of a star. Instead, they require the explosive power of supernovae to come into existence. When massive stars reach the end of their lives, they explode in brilliant supernovae, scattering their newly forged elements across the cosmos. This cosmic debris eventually forms new stars, planets, and everything in between, including us. And here's something that might surprise you. The gold in your jewelry or the silver in your cutlery likely originated from one of these stellar explosions. It's a humbling thought, isn't it? Every piece of gold and silver on Earth is a relic of a cosmic cataclysm, a fragment of a star's dying breath that traveled across the universe to become part of our world. Let me tell you another interesting tidbit. The lightest element, hydrogen, was formed just moments after the Big Bang. In fact, nearly 92% of the universe's atoms are hydrogen, making it the most abundant element in the cosmos. Its presence is so significant that it serves as the building block for all other elements. Imagine the universe as a vast ocean of hydrogen, with islands of other elements scattered throughout. And did you know that helium, the second most abundant element, is actually named after the sun? The element was first detected not on Earth, but in the sun's spectral lines during a solar eclipse. It's a gentle reminder of how our understanding of the universe often comes from looking up at the sky, pondering the mysteries of what lies beyond. As we continue this exploration, consider this. Elements like carbon and oxygen, essential for life as we know it, were formed in the bellies of stars before being released into the universe. This means that every breath you take, filled with oxygen, is a shared gift from the cosmos. It's as if we carry a little piece of the stars within us, binding us to the universe in the most intimate way. Here's another thought-provoking fact. The element iron, so crucial for our blood and planetary cores, was also formed in the fiery interiors of aging stars. As stars exhaust their nuclear fuel, they begin to produce iron, a process that marks the beginning of the end for the star. When a star can no longer sustain the nuclear reactions needed to balance its own gravity, it collapses and often results in a supernova, scattering iron and other elements into space. And speaking of space, Let's talk about how these scattered elements eventually coalesce into new celestial bodies. Over time, gravity draws these elements together, forming clumps that eventually become stars, planets, and moons. It's a cosmic cycle of death and rebirth, where every end is a new beginning. The very soil we walk on, the air we breathe, and the water we drink are all composed of these recycled elements from the stars. To wrap up our peaceful stargazing session, let's ponder the fact that we are all made of stardust. The atoms in your body, from the calcium in your bones to the iron in your blood, were once part of ancient stars that lived and died long before Earth was formed. Isn't it comforting to know that we are all cosmically connected, sharing a heritage written in the very fabric of the universe? Thank you for spending this tranquil evening with me at the Bedtime Lab. May these thoughts of stardust and celestial wonders guide you gently into a restful sleep. And remember, whether near or far, we are all part of this magnificent cosmic dance. Sweet dreams, and until next time, imagine the universe as a vast orchestra, each star playing its own unique symphony. Did you know that while the sun is busy fusing hydrogen into helium, it's also producing a small amount of another element? Yes, it's true. Within the sun's glowing heart, the rare isotope helium-3 is created under the extreme pressure and temperature. This isotope isn't just rare, it's a potential source of future energy for us here on Earth. It's fascinating to think that something so valuable could be produced so naturally in the universe's grand design. Here's another captivating thought. The elements in your smartphone were formed in the remnants of ancient stars. For instance, the lithium found in your device's battery has a cosmic origin story. Unlike many elements, lithium wasn't primarily forged in stars, but instead in the explosive beginnings of the universe itself. Isn't it remarkable to think that something so seemingly modern and ubiquitous still has a connection to the ancient cosmos? Speaking of connections to ancient history, did you know that phosphorus, an essential element for life, has an extraordinary journey? Phosphorus is vital for DNA and cellular energy transfer, yet it's not abundant in the universe. It is believed to be formed in the supernovae and is delivered to planets through meteorites. Imagine that, the building blocks of life, hitching a ride on cosmic travelers, finding their way to Earth. It's a gentle reminder of how intertwined we are with the cosmic dance above. Now, let's delve into the enigmatic world of neutron stars. These stellar remnants, the densest objects in the universe next to black holes, have the ability to forge some of the universe's heaviest elements. When two neutron stars collide, they release an immense amount of energy and create elements like gold and platinum. So, the next time you glance at your jewelry, consider the incredible violence and beauty in the cosmos that contributed to its existence. And here's a thought-provoking fact. Not all elements are forged through explosive events. For example, fluorine, which is found in your toothpaste, is believed to be created in an entirely different stellar environment. Some scientists propose that it forms in the outflows of certain types of aging stars known as asymptotic giant branch stars. These gentle giants, although in their twilight years, still contribute essential ingredients to the universe. Have you ever wondered how elements are distributed throughout the galaxy? Well, after a star explodes in a supernova, the resulting shock waves can trigger the formation of new stars, spreading elements far and wide. This cosmic recycling ensures that no part of the universe is left untouched by the process of starbirth and death. It's as if the universe itself is a master gardener, spreading seeds of creation across the vast expanse of space. Speaking of cosmic gardening, let's talk about how certain elements find their way into your body. The calcium in your bones, which gives them strength and structure, was once part of ancient stardust. This element is essential not just for humans, but for all life on Earth. It's humbling to think that the stars have directly contributed to our very being, making us walking testaments to the history of the universe. Have you heard about the cosmic role hydrogen plays in the universe? As the simplest and most abundant element, hydrogen serves as the fuel for stars. When hydrogen atoms fuse under the intense pressure of a star's core, they form helium, releasing energy that makes stars shine. This process is the very reason we have sunlight, which fuels life on our planet. Every sunny day is a reminder of the underlying processes that power our universe. But have you ever considered the role of oxygen beyond what we breathe? This essential element is also a product of stellar alchemy. Oxygen is primarily formed in large stars during the helium-burning phase and later released into the cosmos through supernova explosions. This journey makes oxygen both a cosmic traveler and a fundamental component of life. It's intriguing to contemplate the path it's taken from the heart of stars to the air around us. And here's something that might just surprise you. The neon that glows in vibrant signs originates from stars as well. This inert gas is produced during the later stages of stellar evolution, particularly in massive stars. When these stars end their life cycle, they scatter neon throughout the universe. Next time you see a neon sign, take a moment to appreciate the journey this element has traveled from the heart of a star to a city's street corner. Consider the element nitrogen, essential for the proteins in our bodies. It is formed in intermediate mass stars and released during the last stages of their life. As these stars shed their outer layers, they enrich the interstellar medium with nitrogen, which eventually becomes part of planets like Earth. It's a continuous cycle, with life on Earth relying on the legacy of ancient stars to sustain itself. Reflect on the element sulfur, often associated with the smell of rotten eggs. This element plays a crucial role in biological processes and is also part of the stellar life cycle. It's primarily produced in supernovae, where the extreme conditions allow for the formation of heavier elements. The presence of sulfur on Earth is another reminder of the intricate connections between cosmos and life. And finally, think about the versatile element aluminum. You might be surprised to learn that aluminum, used in everything from aerospace to kitchen foil, was also born in stars. Specifically, it forms in massive stars and is ejected into space during their explosive demise. Each piece of aluminum you encounter has a rich history embedded in the fabric of our universe. Isn't it extraordinary to uncover the cosmic origins of the world around us? Every element has traveled across light years and epochs to become an integral part of our daily lives. As you drift off to sleep, let these connections to the stars fill your dreams with wonder. Let me share something interesting about the element phosphorus. This vital part of DNA, and essential for energy transfer in cells, has quite an astronomical origin. Phosphorus is formed during the late stages of a star's life when it undergoes fusion processes that create heavier elements. When such a star explodes as a supernova, phosphorus is scattered across the cosmos. Eventually, it becomes incorporated into planets and, ultimately, the building blocks of life. Can you imagine? The very DNA in your cells has a direct connection to ancient dying stars. Speaking of life's building blocks, let's consider carbon. Every carbon atom in your body was created in the heart of a star through a process known as the triple alpha process. This occurs when three helium nuclei collide and fuse to form a carbon atom. What's truly fascinating is that the balance of forces required for this process is so precise that had they been slightly different, carbon might not exist in such abundance. And without carbon, life as we know it would be impossible. This delicately balanced process is a testament to the fine-tuned mechanisms of our universe. And here's another fascinating tidbit. Did you know that silicon, which is crucial in technology and geology, also has stellar origins? Silicon is produced in the cores of massive stars when they reach the silicon burning phase, just before they explode. As these stars go supernova, they scatter silicon throughout the galaxy. This element eventually becomes part of rocky planets like Earth. So, every time you use a computer or walk on the ground, you're interacting with the remnants of ancient stars. Now, consider the element chlorine. Often associated with swimming pools and bleach, chlorine is formed in the fiery depths of stars. Specifically, it is produced during the fusion processes in massive stars before they explode. When these stars meet their dramatic end, they release chlorine into space, contributing to the chemical diversity of the universe. It's remarkable to think that even as you swim, you're surrounded by elements forged in stellar furnaces. Have you ever thought about the humble element iodine? It's critical for human health, particularly in thyroid function, but its origins are anything but humble. Iodine is formed in supernovae, where the intense energy and heat facilitate the creation of such heavy elements. The iodine in your diet, crucial for your well-being, is a cosmic gift handed down through eons. Now, let's turn our attention to the rare and enigmatic element, technetium. Unlike many elements that are stable, technetium is radioactive and naturally rare on Earth. Its presence in certain stars serves as a cosmic marker, showing scientists the ongoing processes within those stellar environments. Technetium is synthesized in stars during their late stages of evolution and is a clear indicator of the complex and dynamic nature of stellar interiors. Speaking of dynamic processes, have you considered where the element copper comes from? This versatile metal, used in electrical wiring and coins among other things, is also a product of stars. Copper is created in supernovae and during the merging of neutron stars, where heavy elements are forged under extreme conditions. The copper in your pocket change carries a legacy of astronomical forces. Let's delve into the story of the element boron. Unlike many elements formed in stellar interiors, boron is primarily produced through cosmic ray spallation. This process occurs when high-energy cosmic rays collide with heavier atoms like carbon and oxygen, breaking them apart to create lighter elements such as boron. It's a fascinating reminder that even the cosmos has its own way of recycling and repurposing materials. And here's something intriguing about vanadium. This lesser-known element, used in strengthening steel, is also a byproduct of cosmic events. Vanadium is formed in the final stages of stellar evolution in massive stars. When these stars explode, they disperse vanadium throughout the universe, where it eventually finds its way into planets and consequently into human technology. It's yet another example of cosmic contributions to our daily lives. Have you ever considered the presence of the element gallium? Known for its use in electronics and LED technology, gallium's origins lie in the cosmic forges of stars. It is produced during the life cycle of massive stars and released during supernova explosions. Gallium is a testament to the intricate processes that bring together the universe's elemental tapestry. Now, let's illuminate the story behind the element selenium. This element, essential for certain enzymes in the human body, is created in the interiors of stars. As stars evolve, they generate selenium through nuclear fusion processes. When these stars eventually end their lives, selenium is scattered into space. It's fascinating to think that an element vital to our health has traveled such a long journey from the stars to our cells. And what about the element lithium? Known for its role in batteries, lithium has a unique creation story. Unlike many heavier elements, lithium isn't formed in stars, but rather during the Big Bang. This primordial element was one of the first to emerge as the universe cooled down. Though some lithium is also produced in certain stellar environments, most of it hails from that ancient cosmic event, linking our modern technology to the dawn of the universe. Turning to the element beryllium, let's explore its origin. Beryllium is a rare element produced through cosmic ray spallation, much like boron. When cosmic rays strike carbon and oxygen atoms, they break them apart to form beryllium. This process predominantly occurs in the interstellar medium, showcasing yet another method by which the universe creates its elemental diversity. Finally, let's consider the story of the element muonium. While not an element in the traditional sense, muonium is a fascinating exotic atom consisting of a positive muon and an electron. Found in the high-energy environments of cosmic rays and particle accelerators, muonium offers insights into the fundamental forces of nature and the behavior of particles at extreme energies. Its existence is a reminder of the universe's complexity and the continuous discoveries that lie in the exploration of its vastness. As you drift into sleep, let these cosmic connections weave through your dreams, reminding you of the remarkable journey every element has taken to become part of our world. Let me share something fascinating about the element silver. Often associated with jewelry and coins, silver's origins are quite extraordinary. Silver is formed in the incredibly violent events known as supernovae. When stars reach the end of their life cycle and explode, they create the conditions necessary to form silver. This precious metal, then dispersed throughout the cosmos, eventually finds its way to planets, including our Earth. Imagine wearing a silver ring that carries the legacy of a stellar explosion. Now, let's ponder the element fluorine. Did you know that fluorine is synthesized in the extreme environments of stars? Specifically, during the asymptotic giant branch phase of a star's life, fluorine is produced in the outer layers. It is then released into the interstellar medium when the star sheds its outer layers, adding to the cosmic abundance of elements. Here's something intriguing. The element scandium, used in aerospace components and sports equipment, is born from supernovae and the merging of neutron stars. Such cosmic events are responsible for the creation of many heavier elements, including scandium. The next time you see a high-performance bicycle frame or a jet engine, remember that scandium's journey began in the heart of a dying star. Speaking of elements with celestial origins, let's explore the formation of cadmium. This element, often found in batteries and pigments, is also a product of stellar processes. Cadmium is synthesized during the late stages of stellar evolution in massive stars and dispersed into space through supernova explosions, contributing to the chemical diversity necessary for life. Have you ever considered where the element radon comes from? This noble gas, known for its radioactive properties, is part of the decay chain of uranium. While uranium itself is created in supernovae, radon emerges as uranium slowly decays over millions of years. It's fascinating to think that even the air we breathe contains remnants of cosmic events. And here's something surprising about the element tin. Used in solders and coatings, Tin is also a byproduct of stellar explosions. In the aftermath of a supernova, tin is one of the many elements that form and eventually become part of the interstellar dust that coalesces to form new stars and planets. Speaking of elements with an interesting origin, let's talk about neodymium. This rare earth element, vital for creating strong permanent magnets, is produced in the extreme conditions of neutron star mergers. These cosmic collisions are some of the most energetic events in the universe, and they forge heavy elements like neodymium. Every time you use a device with a powerful magnet, you're witnessing the legacy of these celestial events. And what about the element tellurium? Known for its use in electronics and solar panels, tellurium is another product of stellar processes. It is formed in the interiors of massive stars and released during supernova explosions, adding to the rich tapestry of elements that make up our world. Can you imagine the origins of the element osmium? This incredibly dense metal, valued for its hardness and durability, is created in the cataclysmic events of supernovae and neutron star mergers. Osmium's presence on Earth is a testament to the dynamic processes that shape the universe. And let's not forget about the element krypton. Not just a fictional planet from comic books, krypton is a noble gas produced in the outer layers of dying stars. During the asymptotic giant branch phase, stars generate krypton, which is then expelled into space when the star's outer layers are shed. Here's an interesting thought about the element yttrium. Used in various technologies, including LEDs and phosphors, yttrium's cosmic journey begins in supernovae. These explosive events provide the conditions necessary to create such heavy elements, dispersing them into the galaxy where they eventually become part of new stars and planets. And let's reflect on the formation of the element indium. Known for its applications in electronics and semiconductors, indium is also a product of stellar explosions. Supernovae create indium, which then becomes part of the cosmic dust and gas that forms new planetary systems. Have you ever wondered about the origins of the element cesium? This soft golden metal, used in atomic clocks and various technologies, is formed in the interiors of stars during their late evolutionary stages. When these stars explode as supernovae, they release cesium into the cosmos, contributing to the celestial abundance of elements. And lastly, consider the element thallium. Known for its use in electronics and optical lenses, thallium is also synthesized during supernovae. Its journey from the heart of a dying star to becoming part of human technology is a testament to the interconnectedness of the universe. As you drift deeper into the realm of sleep, let these stories of elemental origins weave themselves into your dreams, illustrating the magnificent dance of creation that spans the cosmos. Every element, from the everyday to the extraordinary, carries with it a history written in the stars, and through that connection, we are all part of a grand cosmic narrative. Imagine the element iodine, an essential trace element for human health. Its journey begins not in the depths of the ocean where it is commonly found, but in the fiery heart of supernovae. When these massive stars reach the end of their life and explode, iodine is forged and scattered across the cosmos. It's remarkable to consider that the tiny amount of iodine in our bodies has such an explosive origin. Speaking of cosmic creation, let's talk about the element tungsten. Known for its incredibly high melting point, tungsten's formation is a testament to the universe's extremes. It is synthesized in the intense environments of merging neutron stars, where the force of collision generates the conditions necessary for its creation. This heavy metal, used in everything from light bulb filaments to cutting tools, carries with it the mark of one of the universe's most energetic events. Have you ever thought about where the element selenium comes from? It's another product of stellar alchemy, specifically from the interiors of massive stars. During the late stages of stellar evolution, selenium is formed and later expelled into space through supernova explosions. This element plays a critical role in human health and is yet another example of the intricate connection between cosmic phenomena and life on Earth. Now, consider the element technetium. Unique because it was the first element discovered to be artificially created, it also forms naturally in the cosmos. Technetium is synthesized in the outer layers of certain stars during the asymptotic giant branch phase. While it is rare on Earth, its presence in stardust highlights the dynamic processes at work in the universe, crafting elements both familiar and rare. Turning our attention to the element barium, often associated with fireworks and medical imaging, its origin is equally spectacular. Barium is produced in the interiors of massive stars and ejected into the cosmos through supernovae. This adds another layer of wonder to its many applications on Earth, connecting even the most mundane uses to the grandeur of stellar processes. And then there's the element hafnium. Known for its use in control rods for nuclear reactors, hafnium's journey to us begins in the merging of neutron stars. These cataclysmic events are responsible for creating many of the heavy elements, including hafnium, which eventually makes its way to planets like Earth. It's astonishing to think that the elements that manage nuclear reactions are born from the energetic dance of colliding stars. Did you know that the element rubidium, used in atomic clocks and various scientific instruments, also has a celestial origin? Forged in the interiors of stars, rubidium is released into space during supernova events. Its role in precision timekeeping devices connects us to the very stars that measure time on a cosmic scale, demonstrating the intricate relationship between the universe and our daily lives. Speaking of celestial origins, let's explore the element antimony. This element, used in flame retardants and batteries, is born from the stellar processes of massive stars. During their explosive end, supernovae create antimony, dispersing it across the cosmos. This journey from star to Earth showcases the universal cycle of matter that sustains both life and technology. Consider the element zirconium, widely used in everything from jewelry to nuclear reactors. Its formation takes place in the interiors of stars during their final evolutionary stages. When these stars explode as supernovae, zirconium is flung into space, becoming part of the interstellar medium. The sparkling zirconium in a ring is a small piece of the cosmos's vast narrative of creation and transformation. And let's not forget the element tantalum. Known for its applications in electronics and surgical implants, tantalum's cosmic journey begins with neutron star mergers. These powerful collisions produce tantalum, which is then swept into the interstellar medium. Its journey from a violent cosmic event to a component of modern technology highlights the profound connections that span the universe and reach into our everyday lives. Imagine the element molybdenum, essential for plant nutrition and industrial applications. Its origin lies in the nuclear reactions of dying stars. Supernovae create molybdenum, which is later scattered throughout the galaxy. This essential element's presence in soil and technology alike is a testament to the universal processes that bridge celestial events and earthly needs. Now, ponder the element lanthanum. Used in camera lenses and battery technologies, lanthanum's cosmic origin story begins in the explosive end of stars. Supernovae generate lanthanum, dispersing it into the cosmos where it eventually becomes part of the planetary systems. Its journey from starburst to innovation on Earth illustrates the intricate web of cosmic influence. Here's a curious fact about the element cerium. Known for its role in catalytic converters and glass polishing, cerium is also a product of stellar explosions. Formed in supernova, cerium is released into the cosmos, contributing to the chemical diversity necessary for life and technology on Earth. Even the spark plugs in our cars contain the legacy of ancient stars. Lastly, let's consider the element praseodymium. This rare Earth element, vital for creating strong alloys and permanent magnets, is synthesized in the extreme conditions of neutron star mergers. These celestial events, some of the universe's most dynamic, forge praseodymium, which eventually makes its way to Earth. The magnets that power our world are, in a way, reminders of the cosmic forces that continue to shape the universe. As you drift into a peaceful slumber, let these stories of elemental creation guide your dreams, linking the vastness of space to the small wonders of our everyday lives. Let's imagine the journey of the element cobalt, often associated with vibrant blue pigments and essential in rechargeable battery technology. Cobalt's cosmic origins are nothing short of spectacular. It is forged in the fiery interiors of massive stars and released through the powerful blasts of supernovae. When you consider the stunning blue of a cobalt glass or the power of a battery, you're witnessing a piece of the universe's explosive artistry. Now, let me share something interesting about the element bismuth. This element, used in cosmetics and pharmaceuticals, has a unique journey through the cosmos. Bismuth is believed to form in the dying throes of massive stars, in a process known as slow neutron capture. This process, occurring over long periods, highlights the patience of the universe in crafting even the rarest of elements. Speaking of cosmic patience, consider the element indium. Known for its applications in touchscreens and LCDs, indium is another remarkable product of supernovae. The explosive deaths of stars not only create indium, but also scatter it across the galaxy, ensuring that its properties can be harnessed for modern technology. It's fascinating how stars, through their life cycles, provide us with the tools for innovation. Have you ever wondered about the creation of the element thallium? While it may not be as well known, thallium's formation is a stellar tale. It originates in the energetic environments of stars undergoing carbon and neon burning. The expulsion of thallium during supernovae seeds the universe with this element, which eventually finds use in everything from electronics to medicine. This cosmic journey from star to Earth exemplifies the universe's boundless creativity. Let's delve into the element cadmium. Often linked to batteries and pigments, cadmium is born from the same stellar processes that produce silver and tin. Through supernova explosions, cadmium is launched into the cosmos, contributing to the chemical kaleidoscope from which planets and life emerge. The vibrant colors it produces on Earth are a reflection of its dynamic origins in the stars. Here's a surprising fact about the element tin, used in solder and coatings. It is primarily formed in the intense heat of supernovae, where rapid neutron capture processes occur. The ability of stars to synthesize tin and spread it through the cosmos is a testament to their role as cosmic forges. Each time you see a tin product, you're witnessing the handiwork of a star's explosive finale. As we explore further, think about the element germanium. This semiconductor, crucial in electronics and fiber optics, has its roots in the stellar alchemy of neutron capture. Germanium's creation in dying stars and subsequent dispersal through supernovae showcases the universe's intricate methods of element formation. The technology we rely on daily owes much to these ancient cosmic processes. Now, Consider the journey of the element gallium. Used in LEDs and solar panels, gallium's stellar provenance is quite enchanting. It is formed during the C process, a slow neutron capture process occurring in the interiors of aging stars. When these stars shed their outer layers, gallium is released into the cosmos, becoming part of the material that forms new stars and planets. This cycle illustrates the universe's elegant recycling system. Have you ever thought about the element strontium? Known for its role in fireworks and medical applications, strontium is a product of both supernova and neutron star mergers. These celestial events are responsible for creating and dispersing strontium, which adds both color and utility to our lives on Earth. The next time you see a dazzling firework display, remember the cosmic origins of its vibrant hues. Let's take a moment to appreciate the element yttrium. Essential for LED displays and lasers, yttrium is produced during the late stages of stellar evolution and ejected through supernovae. Its presence on Earth and in our technology is another reminder of the star's ongoing influence on our lives. The light emitted by a laser pointer is, in a way, a direct link to the ancient stars that fostered its creation. Speaking of luminous elements, think about the element samarium. This rare earth element, used in strong magnets and certain cancer treatments, is formed in the intense environments of supernovae. Samarium's journey through the universe, from explosive star to vital component of modern medicine, is a testament to the interconnectedness of cosmic and human endeavors. Now, picture the element europium, known for its role in phosphorescent materials and neutron capture therapy. Europium is another product of stellar explosions. Its creation in supernovae and subsequent journey across the cosmos highlights the universe's ability to produce elements essential for both technology and health. The glow of a phosphorescent material is a small echo of its celestial origins. Lastly, let's contemplate the element gadolinium. Vital for MRI contrast agents and high-temperature superconductors, gadolinium's origins lie in the explosive endpoints of massive stars. Supernovae showers the universe with gadolinium, which eventually becomes part of the earthly resources we harness for medical and technological advancements. The ability to see inside the human body with such clarity owes much to the star's prolific element production. As you drift deeper into restful sleep, let these stories of cosmic creation and transformation guide your dreams, weaving the wonders of the universe into the fabric of your imagination. Each element, with its unique journey from star to earth, is a reminder of the universe's perpetual dance of creation. Imagine, if you will, the journey of the element terbium. This intriguing rare earth element is a key component in green phosphors used in display screens, giving life to the vibrant colors we see on electronic displays. Terbium's formation is no less vibrant, occurring deep within the stellar furnaces where neutron capture processes take place. The stars, in their final acts, eject this element into the cosmos, contributing to the myriad of colors we can appreciate today. Isn't it fascinating to think how something so bright and modern has such ancient roots? Here's a curious thing about lutetium. Often overshadowed by its more famous cousins in the periodic table, this element is used in PET scan detectors and special alloys. Lutetium's origin story is one of stellar drama. It is born in the heart of massive stars and further refined during supernova explosions. These cosmic events ensure that lutetium becomes embedded in the dust and gas that form new planetary systems. The next time you encounter a high-tech medical device, remember the celestial journey that made it possible. Speaking of technology, consider the element rhenium. Known for its incredible resistance to heat, rhenium is used in jet engines and other high-temperature applications. But did you know that rhenium is formed in some of the most intense environments in the universe? It originates in neutron star mergers, where the gravitational forces are so strong that they forge heavy elements like rhenium. These cataclysmic events are rare, making rhenium one of the most precious metals on Earth. It's a reminder of the universe's ability to create beauty and utility from chaos. Let's turn our attention to the element osmium, one of the densest naturally occurring elements. It's often used in fountain pen nibs and electrical contacts. Osmium's journey begins in the explosive deaths of stars known as supernovae. The intense energy of these explosions allows for the creation of such a heavy element, which is then scattered across the cosmos. The density of osmium on Earth is a direct reflection of its extraordinary stellar origin. And here's a surprising detail about iridium. Known for its corrosion resistance and its role in the automotive industry, iridium is a relic of ancient cosmic events. It forms in the aftermath of supernovae and is also found in the material left behind by asteroid impacts. Interestingly, a layer of iridium-rich sediment is one of the key pieces of evidence for the asteroid impact that likely led to the extinction of the dinosaurs. The story of iridium ties together stellar explosions and pivotal moments in Earth's history. Now, think about the element platinum. With its uses in catalytic converters and fine jewelry, platinum is both practical and luxurious. This element is created through the rapid neutron capture process during supernovae. The rarity and value of platinum are directly linked to its cosmic origins, as these explosive events are not common. The next time you see a piece of platinum jewelry, consider how it represents a small piece of the universe's history. Here's an interesting tidbit about gold. While its allure is well known, the origins of gold are truly cosmic. It is believed to form primarily in neutron star mergers, where the extreme conditions are suitable for creating heavy elements. These rare cosmic events produce gold, distributing it throughout the galaxy as the remnants of these stellar collisions spread out. The gold we treasure here on Earth is a testament to the universe's grand and rare events. Turning to silver, often used in electronics and currency, its creation is linked to the life and death of stars. Silver is primarily formed in supernova, where the high-energy environment facilitates the synthesis of this precious metal. The journey of silver, from stellar explosions to everyday objects, exemplifies how ancient processes continue to influence our modern lives. Let's not forget about lead, which has a fascinating origin. While we often hear about lead's earthly implications, its creation stems from the star's violent end stages. Lead is the final product of the radioactive decay of heavier elements, a process initiated during supernovae. Over time, these elements transform, weaving the complex tapestry that eventually forms our planet's crust. Now, let's explore the origins of thorium, a slightly radioactive element used in nuclear reactors. Its creation is rooted deep in the history of star formation, occurring primarily through the size process or slow neutron capture in older stars. When these stars eventually exhaust their fuel, thorium is released into the universe, contributing to the raw materials available for planetary development. Consider too the element beryllium, which has a unique story. Unlike many heavier elements, beryllium forms in the aftermath of cosmic ray spallation, a process where high-energy particles collide with lighter elements. This interaction occurs in the interstellar medium, making beryllium's formation quite different from typical stellar nucleosynthesis. When you think of beryllium's applications, whether in aerospace materials or electronics, remember its unusual cosmic journey. And let's pause to ponder cerium, a critical component in catalytic converters that help reduce vehicle emissions. Cerium's cosmic creation occurs during the asymptotic giant branch phase of a star's life. As these stars shed their outer layers, cerium and other elements are distributed into the space around them, seeding new solar systems. The cerium we use today once traveled vast cosmic distances to become part of our planet. Lastly, reflect on the element niobium. Known for its role in superconducting materials and alloys, niobium's formation is tied to the rapid processes in supernovae. The energy released during these stellar explosions allows for the creation of this element, which then becomes part of the cosmic dust that eventually forms planets like Earth. The next time you encounter technology that uses niobium, consider the starry origins that made it possible. As you drift off, let these tales of elemental creation weave through your thoughts, a reminder of the universe's endless creativity and influence. Consider the element tungsten, renowned for its use in light bulb filaments due to its remarkable melting point. Tungsten is born in the cauldron of a supernova, where the intense heat and pressure allow for the synthesis of heavy elements. The next time you see a tungsten bulb illuminating a room, remember that its origins trace back to the fiery end of a massive star. It's quite a journey from the depths of space to a humble corner of your home. Speaking of remarkable metals, let's delve into tantalum. This element, often used in electronics for its corrosion resistance, has an origin story that begins with the R process, or rapid neutron capture, during a supernova explosion. The tantalum we rely on for technology was, in a sense, forged in the heart of a dying star. Isn't it fascinating to think that our everyday gadgets carry a legacy of cosmic events? And here's something intriguing about tin. Although often associated with mundane uses like cans and solder, tin has a stellar origin. It forms during the Circe process in older stars, where neutrons are added to lighter nuclei over time, creating heavier elements like tin. When you open a can, think about the celestial processes that contributed to its existence. Moving on to zinc, this essential trace element for life on Earth has a story rooted in the stars. Zinc is primarily formed in supernovae, where the explosive energy facilitates the creation of such elements. As you consider the zinc in your diet, ponder the remarkable fact that it once roamed the cosmos before becoming part of our planet. Reflect for a moment on the element strontium. Known for its use in fireworks and bone health, strontium's cosmic journey is an interesting one. It forms in the aftermath of a supernova, where lighter elements capture neutrons and evolve into heavier ones like strontium. The vibrant colors of fireworks are a reminder of the stellar processes that bring such beauty to our skies. Think about krypton, not just a fictional substance from the Superman stories, but a very real noble gas. Krypton is formed during the late stages of stellar evolution, often in the red giant phase. As a star expands and expels its outer layers, krypton and other gases are released into the universe. The neon-like glow of krypton lights offers a glimpse into the grandeur of stellar life cycles. Next, let's explore how nickel, often found in coins and stainless steel, is created. It forms primarily in the intense environments of supernovae, where massive stars end their lives. The energy from these explosions facilitates the synthesis of nickel, which is then scattered across the galaxy. When you hold a nickel coin, you're holding a piece of cosmic history. Then there's the element yttrium, which plays a role in phosphors for television displays and LEDs. Yttrium comes to us from the remnants of stars that have undergone the R process in supernovae. The next time you see a bright LED screen, remember that some of its components have a stellar origin, linking our modern entertainment to ancient cosmic processes. Have you ever wondered about the formation of boron? Unlike many elements, boron isn't typically formed in stars. Instead, it originates from cosmic ray spallation, where high-energy cosmic rays collide with interstellar matter. This process creates boron, a vital element for plant growth and glass manufacturing, among other uses. Its unique formation journey sets it apart in the elemental world. And let's not forget vanadium, crucial for strengthening steel. Vanadium's journey begins in supernova explosions, where it is synthesized and then spread across the cosmos. When you think about the infrastructure around you, from buildings to bridges, know that vanadium's strength comes from the heart of a star. Consider phosphorus, an essential element for life, found in DNA and ATP. Its cosmic creation occurs during the supernova phase, where it forms as part of the nucleosynthesis process. As you think about the phosphorus in your own body, it's awe-inspiring to realize that these atoms were once part of a star. Let's delve into gallium, used in electronics and semiconductors. The formation of gallium is tied to the processes that occur in supernovae, where the heat and pressure allow for its synthesis. The next time you touch a smartphone or a computer, remember the divine cosmic dances that play a role in these modern marvels. Lastly, consider the intriguing story of cadmium. Known for its use in batteries, cadmium also originates in the explosive environments of supernovae. When you handle a rechargeable battery, you're engaging with elements that tell a tale of cosmic creation. As you drift further into sleep, let these tales of elemental origins weave through your dreams. Each element, a storyteller in its own right, whispers secrets of the cosmos, sharing the narrative of a universe ever in motion, ever creating, and ever inspiring. Let me share something interesting about cobalt. This element, known for its vibrant blue color, is born in the heart of a supernova. Cobalt forms through the fusion of lighter elements under extreme conditions. Can you imagine the beautiful hues we associate with cobalt, such as those seen in glass and ceramics, originating from such a dramatic cosmic event? This tale of transformation highlights the link between celestial events and the vibrant colors we appreciate here on Earth. Now, think about the element selenium, often used in photocopiers and solar cells. Selenium owes its existence to the processes that occur in asymptotic giant branch stars. During this phase, stars undergo a series of thermal pulses, which lead to the creation of heavier elements like selenium. Isn't it amazing to consider that the light-capturing panels on your roof might contain tiny portions of a star's ancient journey? Speaking of elements essential for life, sulfur is crucial for amino acids and vitamins. But did you know that sulfur has its origins in space too? It forms in massive stars through a process called alpha process nucleosynthesis. As these stars explode, sulfur is expelled into the universe. Every time you crack an egg, think about this delicate balance of cosmic and earthly chemistry at play. Let's explore a lesser-known element, technetium, which is quite fascinating in its ephemeral nature. Technetium doesn't naturally occur on Earth and was first discovered in the stars. This element is formed in the star's process of nucleosynthesis in red giants. It's an extraordinary reminder that while we might think of Earth as our primary source of elements, the universe has its own unique contributions, sometimes quite unexpected. Consider manganese, an element vital for steel production and biological functions. Manganese is also a product of cosmic processes, forming during the late stages of stellar evolution in supernovae. The next time you marvel at a skyscraper or take a vitamin supplement, remember that manganese's cosmic birth helps support both our structures and our health. Have you ever thought about how silver is formed? This precious metal, cherished for its luster and conductivity, originates from the R process in explosive stellar environments. As heavy as it is precious, silver's cosmic origin story adds a touch of wonder to every piece of jewelry or silverware, connecting us to the universe's grand alchemy. Here's a curious fact about iodine, essential for thyroid health. Iodine is created in the violent explosions of supernovae, where intense heat and energy facilitate its synthesis. It's quite something to think that the iodine in your diet has traveled from the depths of space to nourish your body, an incredible journey across time and space. Let's dive into the story of bismuth, a metal with a fascinating crystalline structure. Bismuth forms during the final phases of a supernova through neutron capture processes. Its unique properties and formation story make bismuth a standout among elements. The next time you encounter bismuth in cosmetics or pharmaceuticals, remember its cosmic origins. Then there's the tale of mercury, a liquid metal at room temperature. Mercury comes from stars that have undergone the C process, where it gradually forms as lighter elements capture neutrons. It's intriguing to think that the mercury in thermometers or barometers tells a tale of cosmic evolution, seamlessly connecting the stars to our scientific instruments. Think about the element thallium, known for its use in optical lenses and electronics. Thallium is formed in asymptotic giant branch stars, where it accumulates over time. The next time you peer through a lens, envision the cosmic processes that brought thallium into being, bridging the vastness of space and the intricacies of our technology. Take a moment to consider the formation of platinum, one of the most valuable and dense metals. Platinum arises in the cataclysmic events of supernovae and kilonovae, where neutron stars collide. The rarity and beauty of platinum are matched only by its dramatic origin, a true testament to the universe's ability to create elements of such enduring value. Reflect on the creation of thulium, an element used in lasers and medical imaging. Thulium is born in the heart of stars during the C process, where it forms over millions of years. It's quite incredible to think that thulium's journey from a distant star to a medical device is part of a larger cosmic narrative. Finally, let's consider the cosmic birth of palladium, a metal extensively used in catalytic converters and electronics. Palladium is forged in the explosive environments of supernovae, where it is scattered across the galaxy. This noble metal's journey from the stars to our cars serves as a reminder of the interconnectedness of all things, both celestial and terrestrial. As you let these stories of elemental origins dance in your mind, remember that the universe's vastness is not just a backdrop, but a participant in the ongoing tale of creation. Each element carries a whisper from the stars, a reminder of the grand tapestry of existence. Let me share yet another intriguing story with you about the element neon, which is familiar to us for its bright and captivating glow in signs. Neon is born in the fiery core of stars during the alpha process in nucleosynthesis. This process not only produces elements like neon, but also contributes to the star's dazzling life cycle. So, those vibrant signs lighting up city streets owe their neon glow to ancient stellar forges. Now, let's consider argon, an element that makes up a small percentage of our atmosphere and is often used in lighting. Argon is created through the slow neutron capture process in the outer layers of stars during the asymptotic giant branch phase. This quiet and slow creation process contrasts with its role on Earth, where argon helps preserve historical documents and artworks due to its inert nature. Here's a fascinating fact about iron, a cornerstone of our civilization and the core of our planet. Iron forms in the heart of massive stars through fusion processes that ultimately lead to a supernova. During this explosive event, iron is released into the cosmos, where it eventually becomes part of planets like Earth. The iron in your blood, the backbone of your hemoglobin, is a direct link to a star's ancient death throes. Speaking of which, consider the element xenon, often used in high-intensity lamps and ion propulsion systems. Xenon is a product of the R process during supernovae, where rapid neutron captures create heavier elements. This rare gas, with its luminescent properties, serves as a reminder of the universe's ability to create beauty amid chaos. Did you know that the element strontium, known for its striking red in fireworks, has its origins in explosive stellar environments? Strontium is formed during the CES process in red giant stars, where it slowly builds up over time. The next time you see a firework display painting the sky, think of the ancient celestial dances that brought strontium into being. And here's something marvelous about nickel. Nickel is forged in the core collapse supernovae, where intense pressures and temperatures lead to its formation. This element, essential for stainless steel and many alloys, carries the legacy of a star's final moments, a testament to the cosmos's continuous cycle of birth and rebirth. Think about the element krypton, associated with luminous signage and high-performance lighting. Krypton forms during the late stages of stellar evolution in supernovae, where it is cast into the universe. This noble gas, with its ethereal glow, is a small but significant piece of the universe's grand mosaic. Here's another captivating fact about cobalt, which graces our world with its vibrant blue hues. Cobalt is produced in the aftermath of supernovae, where it is dispersed into space and later incorporated into new stars and planets. The deep blues we admire in art and nature are thus a reflection of cobalt's cosmic journey. Let's explore the story of zinc, an element crucial for health and industry. Zinc forms during the CS process in stars, where it is gradually created over millions of years. This element's journey from stellar interiors to zinc supplements that support your immune system highlights the remarkable connections between cosmic and human health. Imagine for a moment the element yttrium, used in electronics and materials science. Yttrium is born during the S process in asymptotic giant branch stars, where it slowly accumulates before being released into the universe. This element, with its diverse applications, is a testament to the universe's ability to create complexity and utility from stellar processes. Consider indium, a rare metal with applications in touchscreens and semiconductors. Indium is formed in the interiors of stars through slow neutron capture, a process that weaves its atomic structure into the fabric of the cosmos. The next time you swipe your phone screen, think of indium's journey from distant stars to your fingertips. Let me tell you about cadmium, known for its use in batteries and solar cells. Cadmium forms during the CES process in stars, where it builds up over time before being scattered into the cosmos. This element's journey from the stars to your devices underscores the celestial origins of modern technology. Another surprising fact lies in the element tellurium, used in thermoelectric materials and solar panels. Tellurium forms during the Rho process in supernovae, where it is rapidly synthesized in explosive conditions. Its presence in cutting-edge technology is a nod to its fiery beginnings in the universe. Think about the element tin, valued for its use in alloys and electronics. Tin is created during the set process in stars, where it accumulates over time. This element's cosmic origins remind us of the universe's role in crafting the materials we rely on daily. Lastly, consider the story of lead, often associated with its historical uses in pipes and paints. Lead is produced in the late stages of stellar evolution, during the Cetus process, where it builds up before being expelled into the cosmos. Its journey from ancient stars to modern society is a testament to the enduring connection between the universe and human civilization. As you gently drift into a deeper state of relaxation, marvel at the interconnectedness of everything. Each element tells a story woven with the threads of time and space, bringing the universe's grand narrative into our everyday lives. Sleep well, knowing that you're part of this cosmic tale, a chapter in the vast book of existence. Let me share something fascinating about aluminum, an element that is surprisingly abundant in the Earth's crust, but not naturally found in its pure form. Aluminum is born in stellar processes, specifically through the capture of alpha particles in stars. Although it's such a common element today, its cosmic origins are a testament to the intricate dance of particles in the universe. And did you know about the element silicon, the cornerstone of modern electronics? Silicon is formed in the cores of massive stars through a process known as silicon burning, a stage where silicon nuclei capture helium nuclei. This process occurs at incredibly high temperatures, and the silicon we utilize in technology and industry owes its existence to these stellar conditions. Speaking of foundational elements, let's consider calcium, which plays a vital role in both our bones and the mineral world. Calcium forms in massive stars during the late stages of stellar evolution through the calcium burning process. The calcium in your body is a direct descendant of ancient stellar furnaces, a reminder of the universe's nurturing touch. Here's something you might find intriguing about phosphorus, an essential element for life as we know it. Phosphorus is forged in the energetic environments of supernovae, where it is expelled and later incorporated into new planetary systems. Every DNA strand within us contains atoms shaped by these colossal cosmic events, linking our very essence to the stars. Have you ever wondered about the origin of gold, that precious metal cherished throughout human history? Gold is created in the cataclysmic collisions of neutron stars, events so powerful they can be detected across the universe. These rare astronomical phenomena sprinkle gold and other heavy elements into the cosmos, where they eventually become part of planets and even adorn our lives. Now, let me tell you about the element iodine, crucial for human health, particularly in thyroid function. Iodine forms during the R process in supernovae, akin to its heavy counterpart, gold. This element's path from stellar explosions to the salt on your table illustrates the universe's role in nurturing life on Earth. Consider the element selenium, known for its role in electronics and as an essential micronutrient. Selenium is produced through nucleosynthesis in stars, particularly during the S process. The selenium found in your diet, supporting your immune system, traces its lineage back to these distant cosmic ovens. Imagine the element silver, symbolizing wealth and beauty for millennia. Silver is also born in supernova explosions, created during the rapid neutron capture process. Each piece of silver jewelry or coin embodies the history of these fiery cosmic events, linking our cultural heritage to the universe's grand scale. Let's explore the story of bromine, an element used in flame retardants and some medications. bromine is formed in stars through the S process, where it gradually accumulates before joining the interstellar medium. Its journey from stellar interiors to everyday applications highlights the universe's pervasive influence on our daily lives. And consider the element platinum, another precious metal with both industrial and decorative uses. Platinum, like gold, is believed to form in the collisions of neutron stars. These rare and violent events scatter platinum into the universe, making this lustrous metal a symbol of cosmic extremes meeting human elegance. Moving on, think about the element mercury, known for its liquid state at room temperature and use in thermometers. Mercury is created during the late phases of stellar evolution, through a process that involves both the C process and rapid neutron captures. The Mercury that fascinates us with its unique properties is a testament to the universe's ability to surprise and intrigue. Here's another captivating fact about the element lead, familiar yet profound in its cosmic origins. Lead forms through the C process in stars, evolving slowly over millions of years. Each atom of lead tells a quiet story of time, a narrative that echoes through the tools and structures that have shaped human history. Have you ever considered the element titanium, renowned for its strength and light weight? Titanium is produced in supernovae, where its nuclei are created through fusion processes. This element's transition from stellar explosions to aerospace engineering showcases the universe's contribution to human innovation and exploration. Speaking of which, let's ponder the origin of the noble gas radon, known for its radioactive properties. Radon is a decay product of uranium, an element formed in supernovae through the R process. The presence of radon in the Earth's crust is a subtle reminder of the violent cosmic past that laid the groundwork for our planet. Lastly, let me tell you about technetium, an element not found naturally on Earth, but synthesized in stars. Technetium is created in red giants through the S process, and its discovery in stellar spectra provided key insights into nucleosynthesis. This element's stellar origins underline the universe's capacity for producing the rare and extraordinary. As you contemplate these stories, remember that each element carries with it a piece of the universe's history. From the most common to the rarest, every atom in your world shares a cosmic lineage, a reminder that we are all connected by the vast and mysterious processes of the stars. As you drift deeper into relaxation, let these tales of stellar birth and rebirth envelop you, gently guiding you into a peaceful slumber. Let me share something truly remarkable about the element iron. Iron is produced during the final stages of stellar evolution, specifically in the cores of massive stars. When a star has exhausted its nuclear fuel, it collapses, resulting in a supernova. It's in this explosive event that iron is scattered throughout space, eventually becoming part of planets and life itself. The iron in your blood, carrying oxygen to your cells, was once at the heart of a star, ensuring that even the simplest breath is connected to the cosmos. Here's a fascinating fact about the element nickel, often found alongside iron. Nickel is also forged in supernovae through processes that favor the creation of heavier elements. Its presence in the cores of planets, including our Earth, suggests that these celestial explosions have shaped not only the atmosphere, but also the very foundation of the world beneath us. Nickel's strength and resistance to corrosion make it invaluable in countless applications today. Yet its journey from the stars is a story of resilience and cosmic chemistry. Did you know that the element copper, essential for electrical wiring, is also a product of stellar processes? Copper is created in the intense environments of supernovae and during the S process in aging stars. The copper in your home, conducting electricity quietly and efficiently, has traveled billions of miles across the universe to arrive at its destination. This journey from star to socket is a testament to the interconnectedness of cosmic events and daily life. Consider the element zinc, vital for the immune system and numerous industrial applications. Zinc is formed in the interiors of massive stars through fusion processes. Its abundance on Earth is a reminder of the generous distribution of elements resulting from ancient stellar deaths. The zinc that supports your health today is part of a legacy that began in the nuclear hearts of stars, bridging the gap between cosmic phenomena and human well-being. Let's turn our attention to tin, an element used in alloys and electronics. Tin is synthesized in stars through slow neutron capture, a process known as the S process. The presence of tin in our technology is a direct consequence of these stellar activities, highlighting how elements born in the universe's great furnaces find their way into the intricate devices we rely on every day. Here's something intriguing about antimony, an element used in flame-retardant materials and batteries. Antimony is produced in stars through the S process and released into the cosmos during supernovae. Its role in making materials safer is a fitting legacy for an element forged in cataclysmic stellar explosions, illustrating how the universe's dramatic events contribute to our safety and progress. Now, think about the element bismuth, known for its low toxicity and use in pharmaceuticals. Bismuth is created in the late stages of stellar nucleosynthesis through the S process. Its stability and utility on Earth are mirrored by the steady processes that produce it in stars. The presence of bismuth in everyday medicine is a gentle reminder of the universe's nurturing hand in our health. Speaking of stability, let's explore lead's lesser-known sibling, thallium. Thallium is formed in stars through both the Cis process and R process, marking it as a product of both gradual and rapid cosmic events. Though it's less common in nature, thallium's dual origins reflect the universe's capacity for producing diverse elements through a balance of energetic and steady processes. Let me tell you about gallium, an element important in electronics, particularly in semiconductors. Gallium is produced through fusion and neutron capture processes in stars. Its unique properties, such as melting in your hand, are a continuation of the fascinating transformations it undergoes from star to circuit board. Gallium's existence as a bridge between cosmic and technological realms is a reminder of the universe's role in innovation. Consider the element indium, known for its use in touchscreens and alloys. Indium is synthesized in stars through both the C process and the R process, contributing to its rarity. The indium in your smartphone's display is a product of these intricate stellar processes, connecting the lightest touch of your finger to the universe's complex inner workings. Let's delve into the story of neodymium, integral to powerful magnets used in motors and wind turbines. Neodymium is formed during supernovae through the R process. Its magnetic properties, harnessed for sustainable energy, are a legacy of the explosive cosmic events that created it. Neodymium's contribution to green technology highlights how the universe's energy-intensive processes have lasting impacts on Earth's future. Speaking of sustainable elements, think about tellurium, used in solar panels. Tellurium is generated in stars through processes that capture neutrons slowly over time. Its role in capturing sunlight and converting it into electricity is a beautiful reflection of the energy-capturing processes that created it in the first place. Lastly, let me share a surprising fact about xenon, a noble gas used in lighting and ion propulsion systems. Xenon is produced in stars through both the Cis process and R process. Its presence in cutting-edge technology like spacecraft propulsion systems showcases the universe's influence on human exploration. The light from a xenon bulb or the thrust of an ion engine is an echo of the cosmic origins that brought xenon to us, a journey of light and energy stretching across the cosmos. As you ponder these remarkable journeys, let the stories of these elements deepen your sense of connection to the universe. Each one carries a piece of the cosmos within it, illuminating the profound link between the stars and the details of our daily lives. Drift gently into dreams, accompanied by the comforting knowledge that the universe's history is written in every atom around you. Imagine the wonder of the universe, captured in the humble element silver. Did you know that silver, cherished for its luster and conductivity, is the product of explosive star events? Silver is formed during the Rho process, a rapid neutron capture process that occurs during supernovae. These incredible cosmic explosions scatter silver across the universe, depositing it on planets like our own. The silver jewelry or fine cutlery we admire today is a glittering relic of these ancient celestial fireworks. Speaking of precious things, gold's creation is an equally dazzling tale. Gold is also formed during the R process, particularly in the cataclysmic collisions of neutron stars. These rare but powerful collisions release immense energy, forging gold and other heavy elements in the blink of an eye. When you hold a piece of gold, be it a ring or a coin, you are cradling a fragment of one of the universe's most dramatic dances. Here's a fact about the element iodine, essential for human health. Iodine is produced in the interiors of stars and is spread through supernova explosions. Its journey from a stellar furnace to the Earth's biology illustrates the cosmic generosity that provides the elements necessary for life. The iodine that supports your thyroid function is a tiny gift from the stars, a reminder of the universe's nurturing role in life's sustenance. Consider the element platinum, famed for its resilience and beauty. Platinum is born in the violent environments of supernovae and neutron star mergers. Similar to gold, its rarity on Earth adds to its allure, making it a symbol of both luxury and the potent forces that sculpt the universe. Holding a piece of platinum jewelry connects you to these cosmic events, a tangible link to the grandeur of the universe's creative processes. Did you know that Tin's fellow group member, lead, is also a product of stellar nucleosynthesis? Lead is formed through both the S process and the R process in stars. Its presence in the crust of our planet is a testament to the universe's complex alchemy that intricately crafts such heavy elements. The lead that has been used for centuries in various applications is a witness to the ongoing dialogue between cosmic history and human ingenuity. There's something captivating about the noble gas krypton. Krypton is produced during the C process in aging stars. Though it doesn't wear a superhero cape, krypton plays a vital role in lighting and photography, its inert nature capturing the quiet drama of its origins. The glow of a krypton bulb is a serene reminder of the stellar journeys that shape our everyday experiences. Let me tell you about lithium, an element vital for batteries and mental health treatments. Lithium is created during the Big Bang and later in novae through fusion processes. It's one of the few elements synthesized in significant amounts during the universe's earliest moments. The lithium in your smartphone battery is a relic from the dawn of time, an element that has journeyed from the universe's birth to the technological age. Speaking of light elements, helium's tale is both ancient and ongoing. Formed during the Big Bang, helium is continuously created in stars through fusion as hydrogen atoms merge to form this lighter element. The helium you might encounter in a balloon is a whisper from both the beginning of the universe and the ongoing life cycle of stars, a gentle reminder of the universe's consistency and change. Here's an intriguing fact. The element tungsten, known for its high melting point, is created in stars through the S process. Tungsten's toughness and heat resistance make it invaluable in applications from light bulbs to cutting tools. The durability of tungsten mirrors the relentless energy of the stars where it was forged, a testament to the universe's ability to produce elements that endure. Think about the element selenium, often used in electronics and glass making. Selenium is formed in stars through neutron capture processes, a blend of both the C process and the R process. Its role in technology reflects its cosmological origins, bridging the gap from cosmic creation to human innovation. The selenium in photovoltaic cells, capturing sunlight, is another example of the universe's enduring gift of energy. Let's not forget about arsenic, a less commonly discussed element. Arsenic is synthesized in stars through both slow and rapid neutron capture processes. Despite its notorious reputation, arsenic has important uses in agriculture and electronics. Its journey from star to Earth is a reminder of the dual nature of elements, capable of both harm and help, depending on how they are used. And then there's the element xenon, not only a product of the S process and the R process, but also a significant player in the study of dark matter. Xenon's ability to detect faint signals from elusive cosmic phenomena highlights its dual role in both technology and fundamental science. The study of xenon in laboratories connects us with the universe's deepest mysteries, a reminder of the vast unknowns still waiting to be explored. Finally, let's muse on the element cadmium, known for its applications in batteries and pigments. Cadmium is formed in stars through neutron capture during the S process. Although cadmium is not as prominent as some elements, its existence underscores the diverse symphony of processes that create the building blocks of matter. Each time you encounter cadmium, consider the cosmic symphony that crafted it, a melody of creation echoing through time. As you drift into slumber, let these tales of elemental origins remind you of the universe's enduring creativity, a cosmic lullaby whispering through the stars. As you settle into the gentle rhythm of these cosmic stories, let your mind explore the enchanting tale of molybdenum. This element, essential for plant growth and various enzymatic processes in humans and animals, finds its origins in the heart of stars undergoing supernovae. Can you imagine that something so crucial to life's chemistry was birthed from such cataclysmic events? Molybdenum's journey from violent stellar deaths to delicate biological roles serves as a reminder of the complex connections between life and the cosmos. Speaking of essential elements, zirconium is another intriguing component, often associated with its use in ceramics and nuclear reactors. Zirconium is formed in stars through the slow neutron capture process, also known as the SIR process. This elegant cycle of neutron absorption and beta decay in stars gradually builds zirconium atoms, a testament to the universe's patient artistry. When you find zirconium in jewelry or technology, consider its celestial heritage. Moving to another fascinating element, let's ponder on indium. Widely used in touchscreens and solar panels, indium is primarily formed during the R process, a rapid neutron capture process in supernovae. The rarity of indium on Earth adds to its value, and its cosmic creation story underscores the extraordinary processes that distribute such precious elements throughout the universe. Contemplate the next time you tap on your smartphone screen how it connects you to the remnants of stellar explosions. Have you ever thought about where bismuth comes from? Known for its low toxicity compared to other heavy metals, bismuth finds its origins in the universe's grand tapestry through the C process in stars. Bismuth's stability at the end of the periodic table is a lovely reminder of the universe's ability to create balance and order from the chaos of nuclear reactions. It is said to be one of the least naturally abundant elements on Earth, yet its presence in cosmetics and medicines hints at its versatile nature. Consider the element antimony, often used in flame retardants. Antimony is synthesized in stars through both the S process and the R process. Its earthly applications in safety and technology showcase how the universe's diverse elemental repertoire supports our modern life. The next time you see a fire-resistant material, remember the cosmic origins of antimony that help keep us safe. Let's explore the mystery of tellurium, a rare element often used in alloys and solar cells. Tellurium is created in stars during the R process, where environments of intense neutron bombardment rapidly build heavy elements. Its scarcity on our planet is a reflection of the rarity of the cosmic events that create it, adding an element of exclusivity to its applications. When you encounter tellurium in cutting-edge technology, think of it as a tiny piece of the universe's most dramatic elemental symphonies. Now, let's turn our attention to the element thallium, historically used in rat poisons but now a vital component in electronics and medical imaging. Thallium is formed in stars through the S process, its path from star to laboratory illustrating the universe's gift of utility alongside beauty. This element, often misunderstood, represents another facet of the universe's complex bounty, where usefulness and caution coexist. Imagine the role of rhenium, an element critical for high-temperature superalloys used in jet engines. Rhenium's formation is attributed to the reprocess in supernovae, where its atoms are rapidly assembled amidst the chaos of a dying star. The next time you glimpse a soaring airplane, let your mind wander to the rhenium that helps it reach such heights, a direct link to the explosive births of stars. Now consider the element osmium, renowned for its density and hardness. Osmium is formed through the S process in stars, a slow but steady accumulation of neutrons that builds this formidable element. Its applications in fountain pen nibs and electrical contacts remind us of the universe's knack for crafting materials that are both luxurious and practical. Holding a piece of osmium, you hold a fragment of the universe's most enduring elements. Reflect on the element technetium, an element that stands out for its complete absence from Earth's crust due to its instability. Technetium is produced in stars via the S process, but because all of its isotopes are radioactive, it is fleeting in nature. Interestingly, technetium is used in medical imaging, its temporary presence offering insights into the human body. This ephemeral element's existence in the universe is a poignant reminder of both the transitory and enduring nature of cosmic cycles. Let's not overlook promethium, another elusive element primarily found in laboratories and not naturally occurring on Earth. Promethium is synthesized in stars through the R process, and its presence in certain nuclear batteries highlights its rare utility. The story of promethium is one of rarity and potential, a nod to the universe's hidden reserves waiting to be discovered. As we muse on these elements, consider the role of hafnium, an element with applications in nuclear reactors and electronics. Hafnium's creation in stars through the SIR process speaks to the slow, deliberate crafting of stability and resilience, characteristics that mirror its earthly uses. Finally, contemplate the enigmatic polonium, known for its radioactivity and use in atomic research. Polonium is formed in stars during the R process, its discovery and subsequent applications reflecting the dual nature of elements as both a gift and a challenge. The story of polonium is interwoven with history and science, a reminder of the profound impact cosmic elements have on our understanding of the world. As the night deepens, let these stories of stardust and elemental origins cradle your thoughts. The universe's narrative, woven from countless stellar threads, is a testament to the beauty of creation and the intricate dance of time and matter. Rest in the comfort of these cosmic connections and let their wonder fill your dreams. Let's take a gentle journey through the universe's elemental secrets as the night softly envelops us. Did you know that the element cadmium, often associated with batteries and pigments, finds its origins in the stars through the Say process, much like its neighbor zinc? This process of neutron capture slowly creates cadmium, which then resides quietly within the Earth's crust, ready for its myriad uses. The next time you admire a vibrant color, think about the cadmium that lends its brilliance, born from a cosmic dance millions of years ago. Consider the element selenium, commonly used in photocopiers and glass production. Selenium is primarily formed through the S process in asymptotic giant branch stars. These stars, in their advanced age, offer a nurturing environment where elements like selenium can slowly accumulate. Isn't it fascinating to imagine that your everyday office equipment contains whispers of ancient stellar activity? Here's something interesting. The element iodine, essential for human health, is also a product of cosmic processes. Iodine is largely created in supernovae through the R process, where elements are forged in the fiery crucibles of dying stars. As you sprinkle a little iodized salt on your meal, envision the celestial origins of this vital element, bridging the gap between human needs and cosmic events. A tantalizing fact awaits in the form of the element scandium. Scandium, a light metallic element often used in aerospace components, owes its existence to both the C process and the R process. It is quietly scattered across the universe, yet on Earth, it is a rare treasure that enhances our technological endeavors, like a thin ribbon of stardust woven into our modern tools. Speaking of cosmic rarities, let's consider the element yttrium, commonly found in LED lights and certain alloys. Yttrium is crafted in stars through the S process. This elegant process slowly builds the element, which later finds its way into applications that illuminate our nights and power our devices. Imagine the softly glowing lights in your home as tiny reflections of stellar craftsmanship. Have you ever pondered the origins of the element zirconium? Often associated with ceramic knives and nuclear reactors, zirconium is formed through the SIR process in stars. Its journey from the stellar nursery to your dinner table is nothing short of extraordinary, highlighting the interconnectedness of our lives with cosmic phenomena. Now, let us delve into the story of cerium, an element used in catalytic converters and glass polishing. Cerium's genesis lies in the S process of asymptotic giant branch stars, where slow neutron captures craft this versatile element. As you breathe cleaner air, take a moment to appreciate how cerium born in distant stars plays a role in protecting our planet. And did you know that the element tantalum, used in electronics and surgical implants, is a product of both the S process and the R process? This element, with its impressive resistance to corrosion, is a testament to the resilience of cosmic processes. Whenever you use a smartphone or rely on medical technology, remember the tantalum that silently works behind the scenes, a gift from the stars. Consider the fascinating element niobium, often used in superconducting magnets and jet engines created in stars through the SIR process. Niobium is a key player in technologies that push the boundaries of human achievement. The next time you marvel at cutting-edge technology, recognize the stellar origins of niobium that make such advancements possible. Here's a captivating thought. The element lanthanum, vital for camera lenses and hybrid car batteries, also has its roots in the S process of stars. This element, like many others, bridges the gap between cosmic creation and earthly innovation. As you capture a moment through your lens, think about the lanthanum that makes it possible, an echo of the universe's history. Let's explore the wonders of the element praseodymium, often used in aircraft engines and studio lighting. Formed in stars during the SES process, praseodymium adds strength and brilliance to our world. Its presence in the skies and arts reminds us of the universe's enduring influence on our creative and technological pursuits. Reflect on the element neodymium, a critical component of powerful magnets and electric motors. Neodymium is crafted in the stellar furnaces through both the S process and the R process. Its magnetic properties, harnessed for innovation, can trace their lineage back to the chaotic beauty of stellar evolution. Every time you encounter a magnet, consider the cosmic forces that assembled it. Lastly, ponder the story of europium, a key player in fluorescent lamps and LCD screens. Europium is formed in stars predominantly through the S process, its vibrant glow reminiscent of the celestial events that birthed it. As you gaze at a colorful display, think of the europium that enlivens it, connecting your immediate moment to the timeless realm of the cosmos. As you let these stories of cosmic creation swirl in your mind, imagine the universe as an artist, painting with elements across the vast canvas of time and space. Each element, a stroke of color and life, tells a story of origins that are as grand as they are mysterious. Let these tales of stardust and elemental formation lull you into a peaceful slumber, knowing that you too are part of this magnificent cosmic tapestry. Let me share a surprising story about the element technetium. This element is unique because it does not occur naturally on Earth. It's crafted in the hearts of stars through this process and was only discovered here due to its fleeting presence in certain naturally occurring technetium isotopes. Isn't it amazing to think that some elements we know of have entirely stellar origins, appearing on our planet only through cosmic processes and scientific endeavors? Moving on, think about the element promethium, which is almost exclusively found in the remnants of supernova. This element has no stable isotopes, a rarity in itself. Promethium's elusive nature on Earth is a reminder of the dynamic and transient universe we inhabit. What a wonder that we can trace its origins back to the cataclysmic events of a star's explosive end, reminding us of the temporary brilliance in life's cycle. Here's something intriguing. The element samarium, used in high-strength magnets and as a neutron absorber in nuclear reactors, is formed through the CS process in stars. Its dual role in technology and energy production reflects the dual nature of its cosmic birth. Quiet and methodical, yet essential and powerful. Imagine the stellar processes that allow us to harness energy so creatively on Earth. Consider the peculiar tale of the element gadolinium, known for its magnetic properties and used in MRI contrast agents. Gadolinium is born both in the SIRS process and the R process of stellar evolution. This dual heritage makes it a versatile player, much like its applications in medical imaging. Isn't it fascinating to ponder how something so vital to modern medicine has its roots in the life cycles of stars? Let's explore the formation of the element terbium next. Terbium, often utilized in solid-state devices and green phosphors, is crafted in the S process of stars. The vibrant green glow it produces is a tiny echo of the grand celestial processes that create it. Imagine how each flash of green is a nod to the universe's persistent creativity. The story of dysprosium is equally captivating. Used in laser technology and nuclear reactors, dysprosium is a product of the S process. Its presence here on Earth is a quiet testament to the symphonic dance of neutron capture in aging stars. Every time you see laser technology at work, remember the stellar origins that make it all possible. Have you ever wondered about the origins of the element holmium? This element, known for its magnetic properties and used in nuclear reactors, is formed in stars through the S process. Its journey from the depths of a star's life to impacting advanced human technologies is nothing short of remarkable. Each magnetic pull carries whispers of those ancient stars. Then there's erbium, an element that plays a vital role in the telecommunications industry through fiber optic technology. Erbium is formed in stars, its production a result of the S process. Each time you send a message across the globe, consider the tiny erbium ions that facilitate this, connecting humanity with the help of the cosmos. Here's an interesting fact about thulium. This rare element, used in portable X-ray machines and lasers, is also a product of the S process. Its rarity on Earth is mirrored by its creation in specific stellar environments. Think of each X-ray scan as a glimpse into the delicate balance of cosmic creation. Moving forward to ytterbium, an element used in atomic clocks and certain optical devices. Ytterbium is crafted in the CS process. Its stable isotopes, a result of careful cosmic orchestration. Can you imagine how these precise applications trace their lineage back to the stars? The element lutetium offers another stellar story, utilized in medical imaging and as a catalyst in various chemical reactions. Lutetium is produced through the SES process. Its transformative journey from star to Earth shines a light on the interconnectedness of cosmic and human innovation. Let's not forget about hafnium, often used in nuclear control rods and high-temperature alloys. Hafnium, similar to its cousin zirconium, is formed in the stellar nursery to practical applications. Its journey from the stellar nursery to practical applications on Earth highlights the persistent reach of cosmic influence on our technological advances. And here's a curious fact about tantalum's cousin, niobium. Often found together, niobium is key in superconducting materials and jet engines, crafted in stars through the S process. Each time you witness the marvel of modern flight or electricity, consider the stellar forces that shaped such possibilities. Finally, reflect on the element tantalum, essential in electronics and surgical devices, formed in both the S process and the R process. This element stands as a testament to the resilience and utility of cosmic processes in our daily lives. So, whenever you pick up a piece of technology, remember the celestial dance that brought tantalum from the depths of stars to the palm of your hand. As we ponder these tales of elemental formation, let them remind you of the universe's grand narrative, a story written in stardust and cosmic phenomena. Rest easy, knowing that our very essence is intertwined with the stars, a comforting thought as you drift into a peaceful sleep. The universe holds such a tapestry of wonders when it comes to the formation of elements. Did you know that each element is like a fingerprint of a particular star's life, a unique signature of its journey through the cosmos? Take, for instance, the element palladium. This precious metal, often used in catalytic converters and jewelry, owes its existence to the violent supernova explosions of massive stars. Imagine the chaos of these cosmic events, where the heart of a dying star becomes a crucible for new elements. Here's something astonishing. The element silver, known for its lustrous beauty and practical uses, is formed in the stellar forge of asymptotic giant branch stars. These stars, in their final stages of life, shed their outer layers, seeding the universe with silver. It's fascinating to think that the very silver that adorns us has traveled through the vastness of space, a gift from these ancient stars. Then there's cadmium, an element tied closely to zinc in the periodic table and often used in batteries and pigments. Cadmium is produced in the intense environments of supernovae, where the rapid capture of neutrons creates a burst of new elements. The next time you see vibrant cadmium colors in art, picture the supernova fireworks that originally crafted them. Did you know that indium, essential in modern touchscreens, has its origins in the same fiery cosmic events? Its presence on Earth is a direct result of these stellar cataclysms. Every swipe and tap connects you to the universe's explosive creativity. Speaking of explosive, think about tin, often used in alloys and coatings. Tin's formation is tied to both the CES process and R process, weaving a tale of slow and rapid neutron captures in stars. This dual-path creation underscores the dynamic balance of stellar forces at work. Let's not overlook antimony, an element used in flame retardants and semiconductors. It's produced in the S process of aging stars, a slow and steady crafting that belies its modern applications. Imagine the patient cosmic artistry that helps keep us safe and connected today. Here's a curious tale. Tellurium, a rare element used in solar panels and thermoelectric devices, is crafted in the high-energy environments of supernovae. Each time solar energy powers your home, consider the ancient stellar explosions that make it possible. Another fascinating element is iodine, essential for life and commonly found in salt. Iodine's cosmic origin story is equally vital, being formed in supernovae and contributing to the delicate balance of life on Earth. The next time you season your meal, remember the cosmic alchemy that brings health to our tables. Let's turn our gaze to xenon, a noble gas used in lighting and anesthesia. This element is born in the deep interiors of stars during the S process and later expelled into space. It's intriguing to think about how this invisible gas lights our world and eases our pain, all thanks to ancient celestial craftsmanship. Have you ever wondered about the element cesium, used in atomic clocks and GPS technology? Cesium is a product of the S process, a testament to the universe's precision and timing. Each tick of an atomic clock is a gentle reminder of the universe's meticulous handiwork. Speaking of precision, think about barium, often used in medical imaging and fireworks. Barium is formed in both supernovae and the CES process, showcasing the duality of its celestial origins. Its vibrant show in fireworks is a small echo of the stellar spectacles that created it. Consider the element lanthanum, used in camera lenses and hybrid car batteries. Lanthanum's formation in stars through the C process is a story of gradual accumulation, much like the slow charge of a battery powering our sustainable future. Then there's cerium, an element used in catalytic converters and glass polishing. Produced in the CES process, cerium plays a crucial role in reducing emissions and improving optical clarity. The next time you see a clear glass surface, think of the cosmic journey cerium underwent to enhance our vision. Finally, let's reflect on thorium, a potential future energy source formed in supernovae. Thorium's ability to provide energy connects us to the vast untapped potential of the universe's forces. It's fascinating to contemplate the energy solutions that lie within the universe's elemental tapestry. Each of these elements carries a piece of the universe's story within it, a narrative of creation and transformation written in the stars. Isn't it humbling to consider how intimately connected we are to these cosmic phenomena? As you close your eyes tonight, let your thoughts drift through this interstellar landscape, where each element whispers tales of stars and space. Rest well, knowing that your very being is intertwined with the universe's elegant dance.